We're on problem 71, and they ask us, which fraction is equivalent to this thing? 3x over 5 divided by x plus 4 over x plus 2. So the best way to do this, let's simplify the denominator first. So that's equal to 3x over 5. All of that over, let's find a common denominator. The common denominator is 4, right? So that's, if we have a common denominator of 4, x over 4 is, of course, x over 4. Plus, x over 2 is the same thing as 2x over 4, right? So plus 2x over 4, right? 2x over 4 is the same thing as x over 2. And now, if you divide by a certain fraction, that's the same thing as multiplying by its inverse. So this is going to be equal to 3x over 5 times the inverse of this, times 4 over x plus 2x. Let's see what we could do. Well, we could factor out an x here, so this becomes x times 1 plus 2. Actually, 1 plus 2 is 3. I should have said x plus 2x is equal to 3x. I should have done that. That's silly. I shouldn't have done that. I should have said x plus 2x is equal to 3x. Right? X plus 2x is equal to 3x. My bad. Anyway, 3x and 3x cancel out, numerator and denominator, and you're just left with 4/5. 4/5, and that's choice C. It's getting late. Next question. 72. Let me copy and paste this. Word problems. It's good to parse these together. All right. Okay. A pharmacist mixed some 10% saline solution with some 15% saline solution to obtain 100 milliliters of a 12% saline solution. Okay? How much of the 10% saline solution did the pharmacist use in the mixture? Okay, so 10% and 15%. So let T equal the amount of 10%. So let's say amount of 10%. And let's say that F is equal to the amount of 15% solution. I picked T for 10, F for 15. Okay, so the amount of 10% solution plus the amount of 15% solution, that has to equal 100 milliliters. We'll just assume we're dealing in milliliters. That equals 100. And then, how much saline are we going to end up with? So, if we have the 10% saline solution is going to contribute, however much saline we have, how much saline is it going to contribute to the whole? Well, it's 10% saline, so it's going to contribute 10% of that as saline, right? So 10% times the amount of 10% solution tells me how much saline I'm contributing, plus 15% times the amount of the 15% saline solution I'm contributing. This is the amount of saline from that solution. And that equals what? Now, this is interesting. You end up with a 12% saline solution, 100 milliliters of a 12% saline solution. So how much saline total am I going to have when I mix it all together? I had 100 milliliters. It's a 12% saline solution. So that means 12% of this 100 milliliters is saline. So that equals 12. There's 12 milliliters of saline. With this much contributed from the 10% solution, and that much contributed from the 15% solution. So let's see what we can do. So now we have two linear equations and two unknowns. We're ready to solve. So the best thing to do, I want to cancel out, what do they want to know? They want to know how much of the 10% saline solution. So the best thing, we want to cancel out the f's somehow and solve for t. So let's multiply this top equation times minus 0.15, because I want to cancel this out with this. So let's do that. If we multiply times minus 0.15, we end up with minus 0.15 t minus 0.15 f is equal to minus 15. And then if we add these two equations, 0.1 plus minus 0.15, that's minus 0.05, right? Right, that's right. T, these two cancel out. It's equal to 12 minus 15 is minus 3. Okay, we can multiply both sides by -1. You get plus 0.05 is equal to, times t is equal to 3. And sorry, I'm getting messy here. So if you divide both sides by 0.05, you have t is equal to 3 divided by, that's a 3. 3 divided by 0.05. 0.05, that's the same thing as 1/20th. So this is equal to 3 times 20, which is equal to 60. So we contributed 60 milliliters of the 10% saline solution. So T is equal to 60, and that's choice A. And this is a little bit confusing because, you're like, oh, what variable do I use for the 10% solution, and how do I set up the second equation? And a good place to start is say, oh, well, they want to know how much of the 10% saline solution did the pharmacist use, so let me set that as a variable. Let me set another variable for the other type of solution. If I add them together, I have to get 100 milliliters. And then the tricky part was just probably figuring out, okay, how much saline did each of the solutions contribute? And then when you add that up, that equals 12 milliliters of saline. Anyway, next question. Next question, 73. 73. 73. Go. Andy's average driving speed for a 4-hour trip was 45 miles per hour. During the first 3 hours, he drove 40 miles per hour. What was his average speed for the last hour of his trip? Okay, so distance is equal to rate times time. Distance is equal to rate times time. Okay, so his total and for a 4-hour trip was 45 miles per hour, or you could say rate is equal to distance divided by time. Right? That's just divide both sides of that by time. So he said the average driving speed for a 4-hour trip was 45 miles per hour. So 45 miles per hour is equal to the distance he traveled divided by his time, divided by 4 hours. So we can figure out the distance right off the bat. So let's actually do that. So distance is equal to 4 times 45. Distance is equal to 45 times 4. That's what? 40 times 4 is 160 plus 5 times 100, so it's equal to 180. What is it? Miles. The distance is equal to 180 miles. D is equal to 180 miles. Fair enough. They say during the first 3 hours he drove 40 miles per hour. During the first, okay. What was his average speed for the last hour of his trip? So we just have to figure out how much ground did he have to cover. So during the first 3 hours, he drove 40 miles per hour. So how far did he go? If you go, so that's a different distance. That's just the first 3 hours. So the distance over the first 3 hours is equal to the rate of the first 3 hours. It's equal to 40 times the time, times 3 hours. So his distance over the first 3 hours is equal to 120 miles. So how far did he have to travel in that last hour? Well, in the first 3 hours, he went 120 miles. He went a total of 180 miles. So his distance in that last hour is going to be 180 minus 120. He had to go 60 miles in that last hour, right? So how fast did he go? Well, he went 60 miles in that last hour, so he went 60 miles per hour. Choice B. So this might seem like a complicated problem, and it is a little tricky, but it's all about distance equal rate times time, and then recognizing that the second statement, that you could use this first statement to figure out the total distance he traveled. You could use the second statement to figure out how far he traveled in the first 3 hours. And then you know how far he had to travel in that last hour, or essentially how fast he had to travel. Next question. 74. 74. One pipe can fill a tank in 20 minutes. So let's say pipe 1, its rate is equal to one tank per 20 minutes. For 20 minutes. That's how I like to write it. That's what they told us. One pipe can fill a tank in 20 minutes, while another takes 30 minutes to fill the same tank. So pipe 2 is equal to one tank per 30 minutes. That's its rate. Or 1/30th tank per minute. This is 1/20th tank per minute. Fair enough? How long would it take the two pipes together to fill it? So their combined rate is just both of these, right? If you have both pipes going in, you're going to have 1/20th tank per minute plus 1/60th tank per minute. Let's see. 1/20th plus 1/60th, common denominator is 60. 120 is 360 plus 1/60th is 1/60th tanks per minute. It's just adding fractions. So that equals 4/60th tanks per minute, which is equal to what? 4 over 60, that's 1 over 15 tanks per minute. So 1 over 15 tanks per minute, or you could view this as equal to 1 tank per 15 minutes. So how long does it take to fill one tank? 15 minutes. Choice is C. Choice is C. Problem. Oh, I'm all out of time. I'll see you in the next video.